So, good evening and welcome everyone to today's Saturday Talk session. Today, we have a privilege to have Dr. Arunkumar Sampath and he's going to address on the Vision 2030 opportunities and challenges in realizing transition to full EV. Dr. Arunkumar M. Sampath has 27 years of experience in the gamut of automotive and aerospace defense fields, including sustainable mobility, 5G networks, AI and edge computing, HEV, EV, hydrogen and fuel cells, drones and air taxis, autonomous and connected technologies, automotive electronics, cybersecurity, EV charging, etc. Is currently employed in Tata Consultancy Services, that is TCS in Chennai. He was also working as a project lead for the NVH development in hybrid vehicles at Daimler Chrysler Hybrid Development Center in Troy, Michigan, USA. He has written numerous articles on advanced technologies including 5G networks, fuel cells, cybersecurity, urban air mobility, and drive-by-wire electric vehicles, etc. And he is having the core competency on the subject, what he's going to deliver today. Sir, over to you from here.
Okay, thank you very much for the introduction. The association with JanyuTech started about 15 months ago, where I met Shri Abhimanyu Rajaji. So the talk of this lecture today is Vision 2030, Opportunities and Challenges. Because lots of times what we realize is sometimes we keep hearing in the news that the government is taking certain actions, certain initiatives, certain policy initiatives, etc. And you wonder why they are doing what they are doing and what is implication of that. In fact, a couple of days ago, as you may be aware, Shri Nitin Gadkari ji now launched the Bharat NCAP, something similar to the global NCAP or Euro NCAP, the Bharat equivalent of that. And if you look at the statistics, now people are going to purchase vehicles only with this Bharat NCAP safety. They do not want to purchase any vehicles that do not have the safety features or the airbags, etc. But again, the vehicle can only do so much. At the end of the day, it is the driver behavior or the passenger behavior that also makes a difference when we are driving on the road. Okay, so I will take this opportunity to walk through the presentation. This is just an outline. What I wanted to say was, what is the vision? This vision, as you may be aware, was given a few years ago, about 4 or 5 years ago. And then, in fact, I published an article about 3.5 years ago in March 2020, I believe, just around the COVID time, in one magazine, Vision 30. And I will share a glimpse of that in the next couple of slides. And then the FAME incentive, FAME 1, FAME 2, etc. And then the EV architecture and how that is evolving and over the last few years. And because I am currently in the engineering services role, not exactly in the product development role, I have included some slides from my previous association with Mahindra & Mahindra, where we worked extensively on electric vehicles. Then lots of times you notice in India that, a lot of companies, they want to move from the traditional, conventional supplier base to EV supplier base. For example, you have organizations in Chennai or Aurangabad or Nasik or Pune or, the Delhi, Gurgaon area, where they have been traditionally supplying some engine components or traditional vehicle components. Now they want to diversify into EV. So what are the opportunities? What are the challenges? So I have a very dedicated presentation. Then of course, Startup India, Stand Up India. This is a very important thing. In fact, I wanted to include some slides on skills also, but I will briefly touch upon that in the Startup India, Stand Up. Okay. So this is the outline. So what I wanted to show was, so as you may be aware, our Honorable Prime Minister has said, India wants to be self-reliant. India has to be self-reliant. And then he has identified 5 pillars of Atmanirbhar Bharat. For example, economy, infrastructure, the overall the ecosystem, then the demography, because as you may be aware, today India is one of the youngest population in the world. And of course, the domestic demand. One of the biggest challenges that China has today with its deflation is it does not have the domestic demand. It was export-oriented economy. So the biggest challenge for them was the domestic demand. But fortunately for us in India, we have a good domestic demand also. So special economic package has been identified of about 20 lakh crore. This was a few years ago. Fair enough, sometimes the number goes up, goes down, depending on the finance, the budget, etc. But this is an approximate. Approximately accounts for about 10% of the GDP. And as you may be aware, Honorable Prime Minister always insists on vocal for local, because whether it is an aerospace, whether it is automotive, whether it is mobile manufacturing, etc., he says that we should actively promote local manufacturing, local skill development, local job creation, etc. Then focus on land, labor, liquidity, and loss, because sometimes we have these challenges. Even today, the biggest problem in India today is not technology, it is the land acquisition. Whichever project you see, whichever project is delayed, the biggest hindrance for that is land acquisition. Okay? Then these are just the snapshots of some of the stimulus packages. For example, the overall stimulus was provided as part 1, part 2, part 3, etc. And the grand total is approximately 20,97,000 crore. Now, the biggest, the MSMEs, the medium, micro, small, medium enterprises, these constitute a significant chunk of the business. As you may be aware, especially with respect to auto industry or aerospace industry, etc. In fact, you have seen the success of Chandrayaan 3, and lots of MSMEs contribute to the success of different space launches, etc. So these MSMEs are being given a significant chunk of this stimulus package also. Okay? That is the takeaway from this particular slide. Now, these are the 10 dimensions of the government's vision. One is the next generation infrastructure. As you may be aware, we have been seeing fantastic roads, lots of tunnels, railway stations getting improved, airports getting improved, or new airports getting built, etc. The digital India, as you may be aware, just a few days ago, the German minister was trying out UPI by purchasing vegetables in some local market in the Delhi area. And today, Japan, advanced countries like Japan, and sometimes even US, even for example, Europe, Australia, etc., they are trying to figure out how they can utilize UPI payments. Of course, clean and green. So India has taken a very aggressive target with respect to energy transition. I don't know if you know this, but among the G20 countries, India is the only country that has significantly met the targets. We have achieved about 75% of the targets what we have taken up. 75 gigawatts we have already met as part of the G20 initiative. I don't think any other country even comes close. So as you may be aware, we have to be, Honorable Prime Minister talks about ease of living and also the life concept, where he not only talks about the economy, but he also talks about healthy and distress-free India, improving the coastal lines, etc. So with respect to this particular topic, with this particular electrification, what I wanted to touch upon was taking this grand vision, specifically touch upon only one particular aspect, that is the clean and green India. So I had an opportunity to present this article. I can share a link to this article. That is not an issue. This was in March 2020 in the SA India Mobility Engineering Mag. So the challenges today, charging infrastructure development, as you may be aware, even today, whether it is a Ford or whether it is a GM or Volkswagen or whatever, even they are struggling worldwide to build the charging infrastructure. So right or wrong, Tesla has railroaded all of these guys, and they have gone ahead with respect to launching their vehicles, pushing forward their charging infrastructure, charging protocols, etc. So all other OEMs today, unfortunately, they are not in a position to challenge the position of Tesla. So they are adapting what Tesla has done. So because the charging infrastructure development takes time, the protocols take time, the standards take time, but Tesla has gone ahead and they have invested significant chunk of money. So other companies are also now adapting. So India, what is doing is, I think smartly we are trying to bring Tesla now. So there will be a very good competition, not only for the regular vehicles, but also for the electric vehicles. The challenge in India is, previous thought was we should probably have the charging infrastructure as part of the local petrol bunks, whether it is a HP or a BPCL or IOCL, etc. But there are some other thoughts what works for US, China, etc. may not work for India, because India is a predominantly two-wheeler market. Out of say about 24 million vehicles that we produce every year, about 18.5 million vehicles are two-wheel, whereas that is not the case in other countries. So whatever charging infrastructure you build for a four-wheeler, it is not enough if you want the volumes to take off, because you have to focus on two-wheeler. So for the two-wheeler charging infrastructure, what specific states such as say Kerala, what they have actively done is, you have electric poles. So they have proposed the charging box right on the electric pole. And the electric poles are, you don't have to invest in significant amount of infrastructure. And you also have the electric wires running, etc. All you have to do is just ensure that there is a safe system and there is a charging that is available. You may have some 32 amp plug or something like that could be used for charging. So that is being proposed, right? It is still a work in progress, but that may show up primarily to charge the two-wheelers. Okay. Now, as you may be aware, Ola and a couple of other companies, as Pathakji mentioned, Tata, all these guys are trying to build the gigafactories in India now. And the cross-country deployment is a challenge now. So everybody is looking forward to how we can make this as a change looking forward to 2030. Okay. Now, as part of Vision 2030, the biggest, this is the pre-PLI scheme. As part of FAME, what they have come out with, what is called the PMP, Phased Manufacturing Program. This is very similar to your production-linked incentive PLI program also. But in this particular case, what the government wanted to do was, they wanted to identify specific components. I will be honest with you. I don't know if you know, but the government has initiated cases, investigation into lots of companies. Some of the companies are well known. For example, say Hero Motors. What they have done is, they have brought in components from China or somewhere. They did some tinkering and they probably added some software, etc. And they said, okay, this is made in India. So, and they pocketed a lot of the phase the FAME 2 incentive. So the government has identified lots of these loopholes that these guys have done. Though this was done in good faith and a lot of trust was there, but unfortunately some of these even well-known companies have tried to find some loopholes in the system and they were trying to corner the money. So the government has started investigation. So what they have done is they have clearly identified what are the different components, what is the level of indigenization that you want to build. For example, they have categorized this in class A, class B, class C, etc. For example, code A, code B, etc. And they said you have to achieve these things, and only then based on whatever level you have achieved, you are eligible for that level of incentive. So this was already published at least 4 or 5 years ago, but the government was a little lax in implementing it. They thought, the companies would follow this in good faith, but fair enough. The investigations have started. Now they are trying to push the companies hard to comply with these definitions. Now, the previous one was essentially the manufacturing. Now this is the charging infrastructure. So the government, I don't know if you know, they have already identified a bunch of different states and bunch of different numbers. These numbers are probably a little old. They may have changed in the last few months. Some may have gone up, some may have gone down. But at the end of the day, the biggest challenge today in the world is there is no single charging, protocol, charging port. For example, even for your laptop, you go to US, you have a different plug. You go to India, you have a different plug. You go to Europe, you have a different plug, etc. So you have an adapter. So something similar in the electric vehicles also, there is a possibility that you may have to go for an adapter kind of system or maybe some kind of a universal system. So in fact, even for the Apple, as you may know, the EU has taken a call that, only the C-type charging will be done henceforth. No more Apple specific, charging ports kind of a deal. So something similar the governments may have to enforce. So what India has done is smartly is because we have both Japanese who follow a specific protocol called CHAdeMO, and also we have the European vehicles or US based vehicles in India. So we have given an open forum where we said we will support different kinds of charging infrastructure and charging standards, and we will not restrict. Okay, that's the call taken by the government. So what you see here is, for example, this GB/T, etc. is primarily China driven, whereas this CHAdeMO is essentially Japanese driven. So this type 2, etc. is primarily US driven, US and maybe some Europe. So what you notice is, unfortunately, there is not a single charge port or a charge number of pins, etc. that is the same. It is unique for different regions of the world. So what Tesla has done is I will show this in a different slide. What Tesla has done is they have followed their own super connector, supercharging connector, the hardware and the software, etc. and the protocol. So now they are railroading it, and then the rest of the guys are literally following that. Okay. So India will deploy both CHAdeMO and combined charging system, CCS fast charging technology. So we have taken this call about 4 years ago that we will support this. Okay, battery technologies, as you may be aware, technology transfer. ISRO has been using these batteries because of space applications, and they have agreed to transfer some of these technologies to the private industry and also some PSUs, for example, Bharat Electronics, NALCO, etc. So, of course, Tata Chemicals is providing lots of materials, for example, for the anode, cathode, electrolytes, and all those things. So, this is an ongoing process. Okay, so battery technologies, the incentives are given, as you may be aware, to set up the gigafactories, etc. The government has already identified lots of incentives and the PLS schemes under which, for example, LG or Ola or, for example, the Godi from Telangana area, all these guys are setting up the battery. So that is also big. So now the next challenge is cross-country deployment, because typically we have two-wheelers all over the country. The biggest challenge is how do you put the charging infrastructure, not necessarily in the metros, but also in rural or semi-urban areas. And in the urban areas or in the large metros, the biggest challenge is lots of us have moved into what's called the apartment complexes, where we, previously, say 30, 40 years ago, we've had independent houses, but today lots of us live in the apartment complex. So the government is thinking of building what is called the islands of charging infrastructure, like in a desert where you have an oasis, where you have the water facility, where all the animals have to come and drink water. Something similar in apartment complexes, they want to build the oasis of charging infrastructure where all the two-wheelers, three-wheelers, etc. they could probably come and charge. So that is the concept that is being built. Okay, I will move on. Shall we take questions towards the end? Bhushan, is that okay?
Yes, sir. In the end only.
Okay, thanks.
Yes, sir.
So next, what I will do is essentially touch upon the EV tech trends. Okay, so what the vehicles have evolved about 10-15 years ago. I don't know if you know this. In fact, Tesla, when they launched their vehicle, it was called a Roadster. They borrowed the chassis and all the suspension and the wheels and everything from a company called Lotus in UK, and they launched the Tesla Roadster. That's how they started their EV journey about 15, 20 years ago. So now, in fact, Volkswagen at the time, or GM, or any of these guys, what they have done is they have started modifying the existing vehicle architecture to move away from the conventional vehicle towards whether it is a hybrid vehicle or a electric vehicle. It has its pluses and minuses. Pluses is because there is a lot of carryover. You can probably use lots of components. Reusing of the components could be as high as 60-70%. But the challenge is you are limited by the real estate. You can only so much of space to package a battery or to package a motor, etc. So you have certain challenges. So in fact, I worked on these hybrid vehicles from 2005 to 2008, where it was a 4-company joint venture between GM, BMW, Daimler, and Chrysler. I worked in Troy for about 3.5 years. It was a dual mode hybrid transmission. Technology licensed from GM and adapted by all the other companies, whether it was a BMW or Daimler or Chrysler. All of them adapted the dual mode hybrid transmission and built the engines and built the vehicles around the particular dual mode hybrid transmission. So you could see, for example, Chevy Tahoe, GMC Denali, Cadillac Escalade from the GM. Then from the BMW, it was X7. From Daimler, it was ML450. From Chrysler, it was Aspen. Then this one, Voyager, Plymouth Voyager, etc. So there were a bunch of Dodge Durango. So there were different vehicles from Chrysler side, then Daimler side, then BMW side, and also GM and Cadillac side. So the concept was, as you move away from the engine towards a hybrid vehicle, you have a combination of engine and also you have a combination of battery. Now the advantage is you can reduce the engine size. Okay, for example, just for argument's sake, if this is the 2.4 liter engine, you can probably make this as a 1.5 liter engine. The rest of the torque, etc., could come from the motors and synchronize with the battery. But the biggest challenge is, initially, lots of these companies, they went ahead with, for example, in the Europe, manual transmissions are very popular. So they tried to go ahead with the manual transmission option, but they had some struggles to optimize the fuel map, optimize the range map, optimize the torque map, etc. So the lesson learned was it worked very well for the automatic transmission, whereas it had some challenges with the manual transmission. Okay. So I will briefly touch upon the battery. As you may be aware, the company called, Israeli company, I forgot the name. They have already entered into a MOU with IOCL to launch what is called a aluminum air battery. In fact, ISRO is also working with them. They are trying to build a factory somewhere in Uttar Pradesh or somewhere. And so the the industry is evolving away from the lithium ion towards metal air, whether it is an aluminum air or a zinc air, etc. Of course, there are certain opportunities and also some challenges, but this is also where the industry is evolving. Okay. I will share some articles on this. I have published a couple of articles on this. I will share that information also. Now, there are multiple challenges with respect to battery. Number one, the battery should have the enough juice for the driving range. Number one. Number two, it should be able to give enough torque in the specific driving conditions. Number three, the cells should not have any thermal issues because safety is critical. Number four, you should be able to charge the battery as quickly as possible. I mean, it need not be 100%, but at least 70-80%. If you are able to charge in the minimum time, that is also important. Number five, it should be able to handle multiple cycles, because the batteries are typically built for, say, a 10-year period, etc., a 5-year or 10-year powertrain warranty. So it should be able to handle at least 10 to 15,000 cycles. So these are some of the criteria. So and of course, cost is going to be very important. So all of these will come into picture. So quickly, I'll touch upon the Startup India, Stand-up India. So the biggest advantage in India today is India has the third largest startup ecosystem, whereas of course it has its own challenges. Why that startups are evolving in the auto industry is because you have digital disruption. For example, today there is no, I mean, the walls are broken, whether between, say, OEM or a supplier or tier 1, tier 2 supplier, etc. Today you see a smartphone manufacturing company manufacturing EVs also. For example, BYD, they build cells, they build trucks, they build buses, they build cars. So sometimes you wonder what is it that they are not doing. They are doing anything and everything. Similarly, you look at this, let's say, Oppo, one phone, they are doing into phone. They are also building electric vehicles in China. So as you may know, Apple was trying to get into EV space, whereas more on the autonomous and the connected vehicle space they were doing it. So all these walls are being broken, because there has been a significant digital disruption. Lots of companies are figuring out where is it I want to play, what is the area I want to play. Okay, this is where it's evolving, and this is where lots of startups have spun up. So another disruption that is happening is controlled by OEMs towards disrupted to OEMs. As I told you, anybody and everybody is building vehicles, anybody and everybody is building technology, and it is primarily software defined vehicles, what is called SDVs. Okay, so the biggest differentiator for a customer is what is called the in-vehicle experience. Okay, communication as a service, or a network as a service, or software as a service, etc. So this is going to be the biggest differentiator factor. They take your motors for granted, they take the suspension for granted, they take the, let's say, steering for granted, everything is taken for granted. So this user experience, etc. is going to be the biggest differentiator. So lots of companies are trying to figure out how do we play in this particular space. As I told you, India is today the world's fastest growing major economy, but the biggest challenge in India is where are the jobs. Okay, as you may know, there have been significant amount of layoffs. Even though India is a young, so jobs are happening, but India has to create jobs equivalent to 5 Australias in the next, say, 4 or 5 years. As you may be aware, Honorable Prime Minister Modi ji, he regularly conducts the Rozgar Mela, where he hands over, lots of appointment orders, etc. But that's only notional. That may be a few thousands or maybe a lakh or so, whereas we produce tons of graduates every year. So all these guys need to get a job, and you need to have the right skills for the right job. So this is the biggest challenge, right? So lots of companies have gone into different areas depending on where you touch a vehicle. For example, this is like an elephant. Okay, wherever you touch, you will have a startup working in this. Whether it is a sensor, whether it is a battery storage, whether it's a driver safety, whether it is a navigation mapping, whether it's an auto repair, whether it is a ADAS. So different companies have spun off into different areas. Okay, so even I will quickly run through this. For example, as you may be aware, Google has done extensive studies on the autonomous and connected vehicles, and they are also one of the pioneers with respect to driverless cars. Okay, one of the companies in Bangalore, they have done what is called the driver drowsiness detection system. In fact, this has also been done, and I don't know if you know this. Mobileye started as a startup in Israel. Now it was acquired by Intel for a couple of $1 billion. Now they are providing significant amount of collision avoiding technology to multiple automotive OEMs in the world. Okay. Another challenge in the vehicles is, this is an actual picture of a Jeep Cherokee. So ethical hackers have deliberately taken control of this particular vehicle. They hacked into the vehicle through, I think, the in-vehicle infotainment system, IVI, and then they disabled lots of controls, or they made sure that the vehicle, crashed. So this cyber security is a continuing challenge. Even today, it is a challenge. So lots of startups have gone into this particular area. In India, as you may be aware, Honorable Prime Minister has given the NARA, Startup India, Stand Up India. So India has 2 or 3 challenges. Number one, we have some of the most polluted cities in the world. We have the highest amount of deaths on Indian roads. Unfortunately, this number is only climbing. And the biggest challenge is at least 50 to 60% of the fatalities, or sorry, maybe 80% of the fatalities are involved two-wheelers, and they are in, say, 30 to 35, maybe 40-year range. So wherever they are earning for the family, that breadwinners or, they are losing their lives. So this is the biggest challenge. And it has been observed that there is an impact of about 2 to 3% on the GDP of the country because of these fatalities. So now, not only the infrastructure, but also the safety, as you may be aware. Now, the government has mandated that in the passenger cars, 6 airbags are mandatory. That has been given. Now, as I told you at the beginning of this lecture, about 2 days ago, BNCAP, Bharat NCAP also been launched. So the safety is being actively promoted. Of course, in India, because the biggest challenge is we have a large number of two-wheelers. So lots of innovations are happening, not only with respect to making sure the vehicle is stable, but also in what is called driver assistance systems. For example, there are some, I don't know if I have a picture here. Yeah, for example, Intelligent Cranium. This company based out of Pune, they have developed a smart helmet where you have a heads-up display. Whenever there is a vehicle, you have a warning system also. So this was also done. Okay. Then another company called RTEM. Now they are doing not only this advanced driver assistance system, they are also doing the battery swapping, solar power charging, etc. So some of the the innovations are happening in the two-wheeler sector in India also. Okay. And of course, this picture, as you may be aware, this was Ampere, Hemalata based out of Hemalata Annamalai, based out of Coimbatore. So she started this company, Ampere. Now Ampere has been taken over by Greaves. You may be aware. Okay. So this was the pictures of the Mahindra. And then the biggest advantage in India is we can do what is called the reverse innovation. Okay. So these are actual products built by my team about 15 years ago in my previous avatar, where this generic instrument cluster, for example, this is like a Samsung phone. Whether you buy a Samsung phone in Saudi Arabia or South Korea or Sao Paulo, Brazil, it has to work seamlessly. Means it is only the software that changes. The hardware remains the same. You will just change the settings, change the language, change the controls, whatever. Something similar here. We have built what is called a generic flex instrument cluster. This can be fitted on a tractor. This can be fitted on a snowplow vehicle. This can be fitted on a military vehicle. This can be fitted on a, let us say, a road sweeping vehicle, etc. The hardware is the same. It is the software that gets changed. The UI, UX, the screens, the controls, etc. get changed. The hardware remains exactly the same. This is an actual product, completely designed and developed in Nandanam, Chennai, in automotive infotronics. It's a 50-50 joint venture between Ashok Leyland and Continental. And this cluster is, even today, it is manufactured at Continental facility in Ruti, Switzerland, and the German-Swiss border. Okay. This is electronic cam cluster for U-truck. This cluster, even today, it is fitted and it is running on this particular U-truck. And this is also fitted on your tarmac coaches. For example, your SpiceJet buses or Indigo buses, or whether it's an Ashok Leyland bus or any of these buses, you still see this instrument cluster even today. Okay. For example, this has what is called the multiplexing system body control module. In fact, when we had the board members coming from Germany, when they saw these instrument clusters, the body control units, etc., when we demoed them in the couple of months, this was in 2008, 2009 time frame, the Germans were pleasantly surprised. They thought we had to spend tons of money and we needed 1 year, 2 years, but we built the entire prototype in less than 3 months and we made it working. They were pleasantly surprised. And it was showcased in the board meeting. Okay. Again, these are actual pictures. This fusion relay center, it gets fitted onto KAMAZ trucks in Russia. This is the genset engine control panel. Even today, it is fitted on Ashok Leyland gensets. This is a telematics tracking unit. This is fitted on MTC buses or let's say Pune buses, etc. This is the same instrument cluster that we just saw in the previous one. This current sensor, this was imported from I think Germany for almost like 6,000 rupees. Whereas we reduced this price to about 300, 400 rupees, the same unit. So we built this. So skilling is another challenge. So India has to focus on skill. And I have personally taken it upon myself to conduct a lot of Skill India initiatives. For example, different colleges, etc. What we have done is we have provided lots of courses, lots of training, where especially women engineers. Today, as you may know, I was in one of the colleges about 6-7 months ago. The professors were crying. For example, civil engineering departments, chemical engineering departments, mechanical engineering departments, they are being shut down because there are no students. I don't know if you know this, just yesterday or day before yesterday, 10% of the colleges in Tamil Nadu do not have a single admission in engineering. 10% of the colleges, okay? Not even a single student. And most of the students these days are opting for computer science. So the core engineering students, the departments, etc., are taking it. So what we have been trying to do is educate the students on the core engineering values, core engineering skills.
Suppose as an enterprise, as a company, going for some industry or a manufacturing activity in batteries means what should be the technology we pick up and how to go about it, because manufacturing activity is a long-term activity. By the time infrastructure we build up, it should not be obsolete. So how to go about battery manufacturing as a
today
manufacturing
what lot of
business.
companies are doing, whether it is a Mahindra or a Tata or let us say any of these OEMs or let's say JBM, they were trying to import the cells from say LG or Cattle in China or BYD in China or let's say Samsung in Korea, etc. So we were trying to import the cells, build the modules, build the battery packs within India. and of course design and develop the battery management system, the thermal management system, the controls and all those stuff that was being done. But the hardware, the core cell itself was imported. Now this is where I think certain companies, let's say Godi in Telangana, or let's say ISRO along with Amar Raja, these guys are trying to build or of course Ola, these guys are trying to start from scratch. For example, the cell itself, they are trying to manufacture within India. But again, even within the cell, you have a challenge, because you need anode, you need cathode, you need electrolytes, you need separators, you need controls and all those things. So even within the cell, you need specific materials, specific combinations and all that. Even further today, Tiruchi, which was mentioned in the last slide, I will talk about that, Suhas. Just give me 1 second, please. So even the materials that comprise the cell, today unfortunately we are importing it. So unless you do the backward integration, the battery is going to be, it cannot be complete.